And welcome viewers to the daily space weather. We've got more intense activity going on, huge variations in some solar wind parameters, coronal mass ejections. As you can see, they're going on right now. That's just the past couple of hours from the GOES 16 SUVI. We'll show it and lots more stuff. We'll talk about coronal holes and their connection or lack thereof with earthquakes and so on. So, that is what's going on for the past 24 hours from SDO. Now, you may see some wild plasma gyrations happening, and certainly they have been going on for the past 24 hours, the past few days, frankly. That is 30 frames per second. And, of course, there's a sneak peek at all the CMEs that have been going on for the past 24 hours. Yowzers. So, yeah, exciting stuff. And thanks for tuning into the Smash News Network, least busted name in news. Make sure you press the subscribe button if you're new to the channel. Press the like button regardless. Thanks to everybody who supported the channel over the past 6 years as we produce the world's most comprehensive daily space weather content, free from propaganda and chock full of facts. The 10.7 centimeter radio flux is now at 180 solar flux units. A little bit of an uptick since yesterday, and we've got an uptick in the magnetic complexity of the active sunspots. 3 sunspot groups now right on the Earth-facing portion of the solar disk, capable of producing large flares. There's the radio flux over the past year depicted by that black line. That's from solon.info/solar. 180 solar flux units is the radio flux. And if somebody just says a number to you when it comes to science and there's no units, folks, it's meaningless. It's meaningless. The radio flux isn't 180, it's 180 solar flux units. A solar flux unit is equal to 10,000 Janskys of radio flux density. A measurement of flux density for radio waves traveling through space. Here's our space weather enthusiast dashboard, and NOAA's not forecasting any geomagnetic storm conditions. One of those CMEs yesterday, at least, was certainly too stealthy for anybody else to cover. So we covered it. See yesterday's daily space weather video for details. You can find all the content at youtube.com/smashomash/videos. Also, don't forget to check our community posts because there's always some hilarity on the community posts. youtube.com/smashomash/community. So there's Noah's Enlil spiral, and it's not forecasting anything. ESA is forecasting a sputtering coronal hole high-speed stream on the way. So they're not showing any significant CME impacts either. Again, see yesterday's video for our breakdown and the analysis of when you can expect major geomagnetic storms to arrive. This should be a great one because it'll illustrate the surprise of the space weather community who may not have realized that there were major CMEs on the way. Here are the past 4 hours of what Earth's magnetic moment from space likely looks like. That is what a proton experiences when it blasts into Earth's magnetosphere. The past 4 hours of Earth's magnetic moment from space are Geospace Magnetosphere movie for the day. Here's our ground magnetic perturbations map. The ground magnetic perturbations map. And things are geomagnetically calm, so don't expect major aurora at mid-latitudes or anything tonight. But the arrival of stealth CME number 3 of 5 is, well, already showing up. It was moving a little more quickly than even we forecasted. KP2 is the current geomagnetically calm situation from the Space Weather Prediction Center. NOAA's space weather website, KP2 is the scenario. So if you look at the solar wind from ACE, it's not nearly as interesting as the solar wind from Discover. So we are having a high-speed coronal hole wind stream, but wait till you see the massive variations in the data from Discover. So ACE is showing about 2 protons per cubic centimeter at about 550 kilometers per second. Now check out Discover. Wild variations. First of all, I direct you to this lower pane. So that lower pane there, you can see it says 6.57. That's 6,570,000 degrees for the plasma temperature. And if you look way down here, that's only 50,000 Kelvin. So solar wind temperatures here are varying all the way from over 6 million Kelvin all the way down to 50,000 Kelvin. Multiple orders of magnitude variations in the plasma temperature. Also the density and velocity varying by quite a bit. The velocity made it all the way up over 600 kilometers per second. And we have a co-interactive region here. So there's a CME impact happening as coronal hole high-speed stream arrives. And that's what these variations are. That's why it looks like it is sputtering. There are two separate solar wind regimes as Discover orbits Lagrangian point 1. So at noontime, if you look at the sun, don't look directly at the sun, obviously. Out there a million miles is the Discover and ACE spacecraft as they orbit Lagrangian point 1 well outside of Earth's magnetosphere at about 4 lunar distances. Current conditions from Discover are about, let me get a number here. Can I get a number? How about a number? How about one of the latest numbers? That would be great. About 5.7 protons per cubic centimeter for the solar wind density, solar wind velocity here. Elevated, as well as at ACE at 538 kilometers per second. Our GOES magnetometers are fairly smooth here. Seeing a pretty big range, though, in the readings on the magnetometers of the GOES 16 and GOES 18. Next, the heliospheric magnetism. So we were showing that now this is Earth's magnetism. That is the magnetic field way out in the outer portion of the outer Van Allen belt, which is where the GOES satellites orbit. This is the magnetism of the heliosphere. Completely different thing. Don't get them confused. They're not related at all. And let's look at the last image here. There we go. And Earth is right in the middle of a South Pole-oriented magnetic sector depicted there in red. Here's our line of sight field plot. A lot of data there all at once depicting the photosphere magnetism, the solar B field, and polar fields all at once. That is the past 4 days. Which brings us to coronal holes. Now, coronal holes are super important, folks, as they show us the polar field reversal process. So many people know that the solar polar fields flip throughout a solar cycle. You know, from one solar minimum to the next, the poles will be on the opposite sides of the sun. And we've been showing that on the channel since before solar minimum for solar cycle 24 to 25 transition. So here's our line of sight coronal hole plot. And we've got both north and south pole oriented coronal hole features on the solar disk. Here is the last image. And let's move to our SDO wavelength. There's 211 angstroms from SDO ionized iron, one of the many species of ionized iron covered by SDO. And how about if we move to sunspots? So first, a sunspot number. That's somewhat important, right? Oh, and before I move on to that, let's talk about the relationship between coronal holes and earthquakes. There is no established relationship. Do coronal holes cause earthquakes? There's no reason to indicate, there's no indication that they do. Do coronal holes correlate with earthquakes? No, they don't. Or there would be an 11-year earthquake cycle, which there isn't. Just like there isn't an 11-year hurricane cycle. If you want to read about it, you can check out the USGS page. Do solar flares or magnetic storms or space weather cause earthquakes? So yeah, go check out the article. I mean, we would love it if coronal holes could forecast earthquakes, but they can't, regardless of how much misinformation you hear on YouTube from hack frauds who don't understand basic physics and are teaching people how to survive a fictional catastrophe. All right, so back to sunspots. Sunspot number here now dropping for a couple days in a row here. Sunspot number is at about 133. 133 sunspots is the number from Royal Observatory of Belgium. Now, we have an increasing likelihood of large solar flares. Those 3 sunspots right in the center of the disk there, 3716, 3713, and 3712 from north to south, they're all likely to produce large solar flares, the most likely being 3712. As you can see there, over 60% likely to produce an X-class event. So that's pretty significant. That sunspot has increased in magnetic complexity since yesterday, and for that, we thank you. So moving to sunspots here from SDO, there you go. That's the past 24 hours. Not half bad, not too shabby. Let's show the magnetogram next. And if we're a little bit too zoomed out for you, well, we've rotated the field of view here on this so that you can get a great idea of the magnetic shear of that sunspot. So you'll see kind of right in the center region there, you'll see a lot more contrasting regions where there are stark white and stark black regions right next to each other. And yeah, that is increasing the likelihood of sunspot 3712 of producing an X-class event. So here it is in the continuum. So a great example of how you can see major flares out of a sunspot without major growth. It's all about the magnetic field orientation. Here's another quick view of the SDO magnetogram. And once again, there is the continuum. There is a little bit of growth there, but again, the most important thing is the magnetic complexity. No energetic particles at the moment, just some little tiny spikes there. That doesn't really qualify as a proton event. Just like the current pole shift doesn't qualify as a geomagnetic excursion. Were you aware of that, folks? Yeah, maybe it's important to tell people. The current pole shift does not qualify in geologic terms as even noteworthy. The likelihood that the poles are going to flip is shockingly low. And, you have to deal with the basic probability of things in science, so you don't forecast things that are completely fringe unless you have extraordinary evidence to back up your extraordinary claims. Proton flux is flatlined. As far as the X-ray flux, 2 M-class events. In the past 24, the largest flare was an M2.3. M2.3 was our largest flare, and let's move to the SDO. So there you go. That is not half bad. The 131 angstroms wavelength. And not too surprisingly, both those M-class events came from sunspot 3712. It is our T-mass, the most active sunspot of the past 24 hours. Moving right along. To remind you that you've only got 2 more days of spring left, so it's time to get rid of those pastel colors and get your fully saturated summer colors, right? So a couple more days, wear the pastels, and then when the solstice arrives, it's on to summer colors, right? Here's our solar system forecast as the solstice approaches. That's where things will be 5 days into summer for the northern hemisphere, 5 days into winter. For the southern hemisphere, we will have a gibbous waning moon. This is what's going on over our head. We're located in Lehigh Valley, Pennsylvania. You've got Jupiter, Mercury, and Venus. And of course, if you're viewing the morning sky, check it out. You might be able to see Mars rising first, then Jupiter, and then, you won't be able to see it in the morning because Venus and Mercury are behind the sun. Yeah, that makes sense. So the early evening sky, if you've got a very, very low horizon and very clear skies, you might be able to indeed see Mercury and Venus together. Our astronomy photo of the day are some absolutely spectacular images of sprites. Sprites, green elves, purple diamonds, blue horseshoes, whatever you want to call them. These are the lightning above the lightning, which is believed to be equalizing the electrical charge between different layers of the atmosphere. If you want to check it out yourself, perhaps make it your desktop. apod.nasa.gov. There are also links there that will explain what blue jets are. They're, ionosphere altitude type jets. Again, links there to that. Also about the different layers of the atmosphere if you're not familiar with that. apod.nasa.gov regularly puts links on the page to help people learn about space, as the more knowledge people have, the better off they are. Knowledge is power, And misinformation is weakness. All right, so CMEs. We've had some spectacular ones throughout the day today. Quite a few. So that's 81 frames from today. Let's break it down with Lasco C2 and C3. So we're going to go to early this morning. So some minor CMEs, and then out of the east, and then a major one out of the southeast. Now, that one's not earthly directed. Here it is on C3. About 1400. That is way off to the southeast. However, since then, there have been some more. You can see out of the northwest. They're also not earthly directed. So no new CMEs on the way, folks. We'll also show you the view from stereo A. And I wanted to bring this back to yesterday, since this doesn't show any indication that the CMEs from yesterday are on the far side. That one might be the far side, but then this second one is right on the earth side. So one CME with a partial halo, that's far side. Second CME with a partial halo, that's earth side. That will be striking earth early in the day on the 20th. So here's today. And there are today's CMEs from stereo A's perspective. Again, not earthly directed. But let's move on to show our custom coronagraphs, shall we? Yes, we shall. So there you go. There's the synced up information for you, the coronagraphs and the SDO 304 angstroms ionized helium wavelength all together for your convenience and viewing pleasure. And here we've added the 193 angstroms running difference of 60 minutes to show some spectacular contrast. So yeah, lots of plasma motions, just none coming toward Earth, as far as I can tell. If you think we're incorrect, by all means leave a comment and tell us why you think so. So there's just the solar disk by itself. Fantastic imagery there, as you may have come to expect from the Smash News Network least busted name. In news, we'll zoom in a little bit closer and show you the northern polar region, the equatorial region, and the southern. Very nice. And it looks like one of those filaments has not been named in time. The Michael Jordan filament down in there in the southeast, which would be your lower left, one of the largest filaments we've ever covered in the past 6 years, remains intact. Fingers crossed that one becomes an Earth-directed CME. Is it likely to end civilization? There's about a 0% chance it will end civilization. So here's the southern polar region. And look at the size of that Michael Jordan filament. It's so huge that it stretches all the way around the limb and perhaps is even anchored out of sight on the far side there. So properly massive filaments. And a great day to cover CMEs. Let's move on to filaments. Filaments. What do you got? All right, so the Big Bear Observatory there, great at viewing filaments. And about 8 or 9 of them on the Earth side of the solar disk right now. We'll also show the gray imagery to show prominences. And we do have some new active regions likely to be rising there in the east. You'll see some prominences popping up there. So perhaps some new sunspots about to rise in the next 24 to 48 hours. Before we get to bonus features, here are the past couple of hours on the GOES 16 SUVI 304 angstroms wavelength. And yeah, like I said, there is some action going on, to say the least. Not too bad. How you like them apples? Here come bonus features. Satellite charging hazards are first. We have some minor surface charging by low-energy electrons there in Southeast Asia once again, just like yesterday. Not quite as extreme. The GOES electron flux here coming up off the floor, and you can expect that to dip back down rapidly as we have one more major CME on the way, which will be here in hardly 2 days. So that should be exciting. Here's the forecast by NOAA. And that 2-day forecast there will be off by a lot. By a lot. We'll show the layer where it's measured as well, the ionosphere. The F layer is what we're showing here. And if you're not familiar with it, leave us a comment, ask questions. We try to answer all questions on the channel. We certainly do read all comments. Thanks to everybody who's left comments. Don't forget to press the share button after you do so. That's the previous day, raw vibrational frequency. And if that's Greek to you, don't worry. Here's the anomalygram depicting anomaly in megahertz from the 30-day median. So lots of low-frequency anomalies here, and that's because there is space weather striking at the moment. Co-interactive region of a coronal hole high-speed stream, as well as coronal mass ejection impacts, with at least one more, a major one, actually, on the way that I guess everybody has missed. Those are the facts, and I'll be sticking to them. The day that I stop calling them like I see them is the day that this channel closes down forever. Here's our Global Ionosphere Nowcast for you radio and GPS users. The Global Ionosphere Nowcast, another feature of the Space Weather Prediction Center by NOAA. And last but not least, the latest images. So that is the least likely to produce large flares of the 3 center disk sunspots. That one's a little more likely. Those are both beta gamma delta class, barely. But 3712, that southernmost group, is very much capable of producing large events. So there you go. There's a close-up of that. You can see perhaps right in these areas, right in here, got some pretty significant deltas. So that's what's going on for the space weather. Thanks for tuning into the Smash News Network, least busted name in news. We'll see you next time. And until tomorrow, I'll have been your host, Dan, a.k.a. Smash-O-Mash, inviting you to do the math and visit the links below the video. I'm headed back to the bunker because from watching a lot of nonsense on YouTube, I have become spooked of space.